Good evening, all. How are you, everyone?
Good evening, ma'am. Fine, ma'am.
Okay. So have you started working with the SystemVerilog test bench and have shared the register program, right? So did you try with them? Any doubts from the last session? In the last session, we have discussed on UVM agent and the flow between sequence, sequencer, driver, how the transition flow, and what are the methods and different how to write the programming we have seen on that. And today we are going to discuss on UVM phases. Okay. So can you, I think I already given the overview of phases, right? What is the use of phases in UVM? Why not we are using in system Verilog and what are the difficulties you are facing in system Verilog while we are doing the simulation? So how we are going to overcome with those and what is the use of phases concept? Today we will discuss clearly. Okay. So meanwhile, if anyone have some idea regarding the phases, you can discuss. Hello. So what is the UVM phases and what is the use of the phases in UVM? What are the different type of phases out there and what is the use of each phase? Hello.
Ma'am,
Am I? Yeah, please go on.
phases is used to synchronize the components, ma'am, because
Okay.
we have different phases like build phase, run phase, and we have end of elaboration likewise, and different components take different time. So to have some synchronized time, that is, if we are in build phase, then every component should build. Some component take some more time. So to synchronize that and to proceed in order, we are using phases concept.
Okay. Fine. Any others? Any answers from others? No? Okay, so basically UVM used for synchronization purpose, as he told. Okay, in a structured execution, we can follow the structure wise. Okay, it organize the test bench execution in a systematically. Okay, like it support small and large verification environments efficiently, and also it provides the clear separation of different verification stages. Okay, so different verification stages means what, at the starting time we need to create the components first. We need to create the sequence, driver, monitor, scoreboard. First we need to create, or first we need to take the instances or create, and then you we need to make the connections between each component, and then we need to start our own functionality. So what is the functionality of sequence, what is the functionality of driver, monitor? So everything we need to write. Okay, so and then we need to check every process of simulation, whether the test is executing enter into the main or not. Okay, so like a simulation phase and check phase, we need to check whether the output is getting correctly or not. And also we need to check the verified result and also expected values. Okay, we need to extract all the data, coverage data, or if you use the RAL model, we need to extract all the data from DUT. Okay, so everything will be done in a particular phase wise. Okay, in a structured way, not all the things in a clumsy. Okay, suppose if you don't use any phases in system Verilog, how do we write like all or task based. Okay, so initially in generator, we create the class by using the constructor, and we create a task, like a small normal task body. Inside that we do the randomization and also putting into the mailbox. In the driver, we will get the data from the mailbox and sending to the driver. Okay, but will it working everything in the same at the same time in a structured way? Is it following any timing, proper timing? No, right? So mostly sometimes we the synchronization at the output side, we will get everything correctly, properly, but internal simulation delays, timing violations will be there. Okay, so to avoid that thing, we are going to take some structured path for execution, for simulation execution, and different verification inside that debugging. In suppose if you are doing some debugging to find some verification efficiency, definitely these phases will be useful. And also it simplifies the execution of different test scenarios. From minimal verification, minimal methods we can use. Okay, so for that purpose, phases concept is mostly used. And another thing, in SystemVerilog, mostly we will write in a task. Okay, let me show. So if you see here the generator block in SystemVerilog, we are creating the class, and also we are creating the function constructor. If anyone there in lobby, try, can you please admit? So here we are using everything with a task, virtual task, start method, and we are writing some for loop or any repeat loop, and writing some generating the randomized values and putting into the mailbox. And in generator also will do same, getting the data from transaction to sending the data to the DUT. So everything we are writing in the task. Task means obviously it takes a delays. In task we mentioned the delays, right? Mostly task are not preferred in UVM phases. Why? Because I will tell you. So as we are using the task here, obviously it takes some delays between each, and the functionality, all the functionality is not in a synchronization. Okay, so for that purpose in UVM we created the phases. So everything we plan into the structured way. So when we need to create the component, when the component should be connect, like a monitor, driver, sequencer, and if any final configurations are there, any modifications are there, so when we can make the final finalizing some configuration, or like enable or disabling the components, everything we can check in the start of simulation phase, start end of elaboration phase. Like that we have start of simulation, run phase, extract phase, check phase. So based on all these phases, we are just making some timing between all particular uh, execution in the UVM. Okay, nothing but one structured way. We are just making into a structured way to provide the build, configure, and executing the test benches. Okay, so in that, what are the different UVM phases? Are there mainly advantages like scalability, debugging issues we can easily figure out, and also reusability by using the phases, and mostly structured execution. Okay, so disadvantages in the sense, suppose while we are learning, as you are a fresher, in SystemVerilog we don't use any phases concept. Directly we write the test task. Okay, so we don't feel any difficulty. So directly we do the randomization and putting into the mailbox. In driver we just directly sending the transaction data to DUT. So we never face some difficulty. But in UVM, while we are writing the phases, first you need to understand the concept of each phase. So which phase should be put in which file. Okay, so how we need to access, and what are the function based phases, and what are the task based phases, and which cases we need to use each. So it is like a steep learning curve. Okay, but there are a lot of advantages by using the phases. Okay, so it is like overhead due to extra structure execution while simulation, and debugging is also complexity sometimes, but debugging is efficient. Okay, so these are like minimal disadvantages. Okay, but compared to these, to verify at SOC level, while we are connecting lot of IPs in one virtual sequence, these phases are helpful for connecting multiple blocks at one level. Okay, so what are the different phases are there in UVM? Every phase is important. Okay, mostly all phases are important, but every time we don't use all phases in the example. Whatever the test you are running, we don't use all the phases. Most used phases are, I will explain. Okay, so first one is a build phase. So what is mean by build phase? In build phase, we will construct the test bench components. Okay, that means suppose we have a agent. In agent, we already discussed what is mean by active agent, passive agent. If it is an active agent, there will be a sequencer, driver, and also monitor. And monitor will be connected to some scoreboard or any coverage analysis or any RAL model like this. Okay. So in the build phase, we will just declare this. We will just create. Okay. So what is the sequencer? What is the driver, monitor, scoreboard, like that we will top level, just we will create internal components. Okay, but connections we don't make in the build phase. There is a connect phase here. Okay, in the connect phase, component like these sequencer to driver, driver to monitor, or driver to interface, interface to monitor, these connections would be happened in the connect phase via TLM port. Okay, here we use the TLM port concept. Based on that, we do the connection. In the connect phase only, we use the TLM port concept. Okay, so individually in sequencer, we just create this, and driver, we just create the driver block. In monitor, we just create the monitor block. But where these three will be connected? In the top level agent. And the scoreboard, this agent, where it will be connected? In the top level environment. Okay, and this environment will be called from the test. Okay, this is how the connection will be happened from bottom to up and up to down. We have two type of things. Build phase means up to down, connect phase means bottom to up. I will tell you what is the difference between each in terms of execution. Okay, clear everyone till here?
Yes, ma'am.
Any doubts? Okay. Next, end of elaboration. End of elaboration means like after connecting all the things at the runtime. Okay, if you want to make any changes, runtime means what? Maybe you will think like what will be there in the run phase, runtime, because whenever we are running the test, immediately we will get the output, right? Then what is the need of making the changes in runtime? But actual thing is in SOC level, if we talk in SOC level, okay, so while we are running some test bench, test case, so whether it is a C based test case or UVM based test case, whatever we are running the regression, after regression, whenever we do some debug, okay, after fixing some error. So that is what runtime we call. After fixing some error, the test will be run. Okay, so that's what runtime. The test runtime will be some tests will be small running tests, slow. I mean, small running tests in the sense immediately the test will be completed within a 1 hour. The test will run, complete the run, and get the execution. I complete the execution and get the result. Okay, but some test cases will take 1 day, 2 days, 3 days. Long run test cases will be there. Okay, so in that long running test cases, whenever you want to modify something, suppose after some modifications you did the test run. If it is a single hour test, after test execution we can directly change the value or change the modification. But if it is a long running test case, some test cases will take 2 days, 3 days. Okay, that time in the middle, in the second day, you want to change some modifications. Okay, so that time whenever you change that modifications, those should be reflected the output after third day. Whenever it is completed, those changes should be reflected at the final stage, right? So here whatever we are writing something, whatever we are making final modifications, we need to make in the end of elaboration phase. Okay, so that means it change in the runtime. So whenever the test is running, eh, whatever the modifications we do, it change in the runtime. So those modifications will be getting at the result time also. Okay, so some in Verilog, whatever in Verilog sometimes, or even in system Verilog also sometimes, if we don't make it a runtime or any virtual, um whatever the modifications we did, it never reflected the output side, because those are not running in a those are not changed in a runtime, mostly in Verilog. Okay, that too, whatever we are running now, these are like immediate test cases. So we are not running a long time. Okay, but in server, in industry, whatever the tests we are working in SOC level or IP level, there will be lot of hundreds of thousands of tests will be there, long running tests and slow running tests. So in that time, these things will be helpful. Okay, which are changed in the runtime execution. Okay, and next, start of simulation phase. Start of simulation phase means a topology. So we know the reporting mechanism, right? So reporting mechanism means macros, UVM info, UVM warning, UVM fatal error. Okay, so these type of statements we will write for displaying something at the output side. In system Verilog, we use dollar display, dollar monitor. In Verilog also dollar monitor, dollar display, dollar strobe. Like that in UVM, we use these reporting mechanism macros. Okay. So while we are using these macros, in the first day, I have shown you how the table is execution at the output side. Suppose address, some data is there. Like this, the table will be executed, or sometimes the tree type will be executed in a flow. First, all the things will be executed from variable, and then next. So there are different ways how should be getting at the output side, whether it should be in a table format or in just normal one-to-one output display. Like that we have structured those things. We can write in the start of simulation phase. Okay, it print the test bench topology before execution. Next, run phase. Run phase is the main in UVM. Why? Because whatever the simulation is there, whatever the functionality, everything we put into the run phase only. Okay, so you already know. Suppose in sequence we are doing the randomization, or in the driver we are getting the data from the sequence. Okay, so there we need to write the run phase. So run phase is a main task execution. And next, extract phase. Extract phase in the sense here it will collect all the test statistics. That means till where the test is run. Okay, whether the test is getting any errors, the coverage report, everything will be checked in the extract phase. Okay, the coverage report also will be generated, not totally, just overview. So whether we have this stuck at some test or not, we'll get the statistics at extract phase. Okay, and next, check phase. Check phase means it verify the test results, whether it is pass or fail. That is what check phase. Okay, it verify the result expected or not. And next phase is report phase. Report phase generally final reports we use for final reports. Okay, after all test is passed or failed, final report in the sense Suppose test 1, test 2, test 3, test 4. So related to the test, whether test is pass or fail, test is pass or fail. If test is pass, okay. If test is fail, at what line the test is failing, whether the test is failing with a compilation error or any test execution error, the main functionality error. It will be checking that like a regression report. We'll get the regression report, right? So test ID with the test ID, test name. So debugging error. For the debugging error, it will give some path also. Okay, so that path will, everything will be given in some report. That's what we call as a report phase. Okay, next, final phase. Final phase in the sense clean up resources and finish the test. Here all the tests will be finished. That's what final phase. Okay, clear till here everyone?
Yes, ma'am.
Yes, ma'am.
Okay, next, so here if you see build phases, in build phases, uh, total all these phases will be divided into three types: build phase, run phase, and cleanup phases. Okay, so in build phases there will be build, connect, end of elaboration. In run phases, start of simulation and run. In run again we have sub, like reset. First we do the reset in a driver, right? A reset and a configure in the sense a configuration db. So we'll get the data and set the data. Last time I have shown you. And main phase. Main phase means in this main phase we will write like a body, not body. Main phase in the sense, suppose in sequence in the sense randomization is the main, and in the driver sending the data to dut is the main. So that is what main phase. And shutdown phase, finally shutdown in the sense last total final display statement or if else statements, like that. Okay, so these are run phase. And coming to the cleanup phase, cleanup phase or nothing but extract, check, report, final phase. Okay, so you need to learn about all the phases better. You can remember, you need to remember all the phases. Okay, any doubts still here?
Not
Do
in
you
this,
have any
ma'am.
example of the end of elaboration?
Yeah, we'll write the program. Theory wise everything is clear.
Yeah.
In SystemVerilog, you told like since we don't use phases, there will be timing violations internally. Like
Mm.
what is those timing? Because like anyway the
In
output will be
SystemVerilog,
like
do you heard about the events? Events, active
yes, ma'am.
region, reactive region, blocking, non-blocking regions. So in SystemVerilog we have regions. That means in active region only particular statements will be executed, like a dollar display or dollar monitor. In reactive region some type of statements will be executed. Let me show.
Okay.
So this is what like previous time slot, current time slot, and regions for SV commands. So prepone region or active region. In active region, what are things executing? Blocking assignments and RHS. In non-blocking assignment, the RHS value will be evaluated in this particular active region. Continuous assignment statements, whatever we are writing using assign, those statements will be executed in the active region. Dollar display statements will be executed in the active region. Like that in active region, at zero simulation time. Whatever the statements, blocking assignments are there, those are executing at zero simulation time. Like that NBA region, NBA statement, non-blocking assignment statements will be executed. Like that for new SV commands, these type of regions are allocated, like observed region, reactive region, like that, and prepone, postpone region, dollar monitor, dollar strobe. So like that, every execution particular time slot is divided in SystemVerilog. Okay, so because of this particular time slot, maybe we don't have proper structure which one should be executed first and which one should be executed last. Okay, all are executing parallelly. Okay, in the active region, all these blocks, from every block, all these things will be executing parallelly. And here also, maybe at the output side we don't find lot of difference. Finally at output we will get same, but internal, long, as I told you before, right, long running test benches or test cases, whenever those are running, internally lot of issues we will be finding. Okay, so we will get every statement will be displayed. So if you observe, whenever the test enter into the main phase, so whenever it is executing line by line, suppose in SystemVerilog there are 10 number of lines. So one is a task related, one is a blocking assignment related, one is a display statement related, one is something non-blocking related, and that in this one module there are lot of things. Okay, but all these things are executing in different regions. Okay, even they are all in serial, one by one line should be executed, but still they are not executing in one by one line. Maybe minor, very little timing difference will be there, fraction of seconds, not even seconds, very minor timing difference will be there, but still they are not executing in a sequential manner. Okay, there will be lot of region difference will be there, timing region difference will be there. Okay, so to avoid that thing, in UVM, everything we structured. In build phase, only we need to create the components. In the connect phase, we need to make the connections. In the end of elaboration, we just need to do the modifications, final modifications. In start of simulation, we need to start the next process of simulation. In run phase, mainly all the task must be, main functionality should be executed only in the run phase. And extract phase, check phase, like that we divided everything in terms of structured execution plan. Okay, so here next thing is coming to the build phases and cleanup phases. These two are function based. We need to declare as a functions. Okay, build phase is a function, function connect, function end of elaboration, but only run phase is a task, and remaining here also functions only. Okay, can you tell me why only run phase is a task and remaining all are functions?
The run phase is the one which consumes time.
Okay.
And that's why we need to have everything which takes times and delays in the run phase.
Okay.
We don't have timing constraints in them in timing control functions. We do have only in the tasks.
Okay. Any other answers? No? CB? Okay, so task and function we will discuss after writing some code. As you told that, okay, task is like long running execution and also it contains delay. Functions, all functions will execute at zero simulation time. It doesn't consist any delay. So these build phase, connect phase, end of elaboration, all these things we need to done at a zero simulation time. Okay, we need not to put any delays. So what happens if we put delay? Or even if you use the task, maybe you have a question, I want to use the task for build and connect and elaboration, but I don't want to mention any delay. So is it possible to put? But I can say it is not recommended. Okay, so functions are executed at the zero simulation time, and task execute at some delays will be there. Okay, we will discuss after writing some program. So that's why mostly functions are not preferred, tasks are not preferred for build phases and cleanup phases. Only it is preferred for run phases. Okay, so next if you see here, zero simulation time, consumption here also, but here more time consumption. Okay, so phases synchronization. Before I have told you, right? So we are going to divide everything in terms of phase one, like suppose phase two, phase three, phase four. Okay, in events, we have seen in events. Suppose we are using two blocks. Okay, in active region some non-blocking statements are printing, and in second one, in active region some other non-blocking statements are printing, and in prepone region or postpone region some other statements are printing. Okay, so in the first block, whenever this active region is execution completed, immediately it will go to the prepone region and start the execution here. Okay, but whenever it is completed at this time, at second block it may not complete the execution till this time. Okay, after here it may complete the execution of that non-blocking region and then go to the prepone region. So something there is no synchronization between the regions here in system verilog if we talk. Okay, but we can avoid this type of asynchronous nature. Okay, in UVM. Okay, so if you see here, component 1, component 3, component 2 and 3 all are working at a same simulation time, all are running parallelly. Okay, so when all are running parallelly, at this point of time here, reset task is completed. Okay, so when reset is completed, immediately it should start configure stage from here itself. Okay, and here reset is taking long time. So after long time, whenever it completed, then only it can able to start configure. And here reset is completing at this point of time, so immediately it should start from here. Okay, so whenever it start from here, one is starting fast, one is starting very late, and here somewhat medium level. Okay, next main phase, suppose main phase is starting here and here and here, and shutdown is starting at some point of time, here at some point of time, here at some point. And finally, when we are getting some output, there is no synchronization between each components, right? All are not doing at particular time, all are not in a mutual exclusion. Okay, so that's why for that purpose we are making here the phase, we are using the phases concept. So reset means this particular time is allocated for reset, even it complete fast or even it complete slow, until last one is completed, then only all three must be get into synchronization and go with next state. Okay, so here this component 1 and component 2 will be waiting for till component 2 should be completed. Okay, so once component 2 are completed, so all three are getting in sync and then starting with the configure task. And here also one is completed fastly, now second one is completed fastly, but still it should wait till third one is completed or not. Once third one is completed, so how we will get whether how we will get the signal whether it is completed or not, means here we'll have internal code. So when to get the data and when to follow the next step, like phase phase objection and rise objection, drop objections will be there. rise objection and drop objection, those things will be there. So through that also we can communicate and we can know which one is executing slowly and which one is executing fastly. Okay, based on that we make the synchronization. So here also still second one is completed, first one and third one should be wait, and here also, so that finally at same simulation time we will get the proper output. Okay, all components will be in sync. Clear here, everyone? Yes, ma'am.
Yes, ma'am. Ma'am, rise objection and drop objection is only for run phase, or we can use it for other
We
phases
will
also?
use in the we will use in the task mostly in the run
Oh,
phase.
okay, when it comes to task, we use run phase, so it is comes under.
Yes.
Okay, ma'am.
So we will write some program for all. So then
Prasanti, one question. You have mentioned about the preponed phase. What is that actually?
where in UVM?
I mean, I think no, I think you discussed
Here,
SystemVerilog.
preponed regions. Yeah, here. Postponed region. That means whatever the next statements are there, it goes to the next time slot. Postponed region in the sense remaining. So after test execution, if still anything is there, those will be executed in the postponed region.
I think upside also it's there, like preponed.
Yeah, preponed region means before this simulation task. So from previous time slot, whatever there, so it will complete the execution at this time slot, and in the current time slot, active, inactive, all these things will be started.
Okay.
Preponed and pre-postponed. Pre-postponed in the sense same. After this non-blocking assignment region, still if any statements are there, then that will be executed in the next time slot. Before time slot, next time slot. Preponed or before time slot, postponed or next time slot. In current time slot, these things will be executed.
Hi, can you repeat about this preponed and postponed again? I couldn't get it.
Preponed in the sense before time slot. So if you see here before time slot in the sense initial at zero simulation task or any like compilation things will execute in a zero simulation time only. Okay, those things will be executed in the current time, previous time slot. In current time slot, main functionality is executing in active region, inactive, non-blocking, observed, reactive, like that. Pre-postponed region in the sense final statements, if anything, final adjustments are there, those things will be executed in the pre-postponed event runtime errors.
And these are valid also for the UVM or just for the SystemVerilog?
No, only for SystemVerilog. In UVM we have phases.
Okay, got it.
Okay, because in UVM, do we use all these dollar display? These things we don't use, right? Blocking assignments, non-blocking assignments. Okay. So how do we write the phases in UVM? First, build phase. Last time we did you remember how to write the build phase? First of all, in which
Yes,
block
ma'am.
we write the build phase? In environment.
In agent we built
Top level. Top level is agent for driver, sequencer, and monitor. So here we will write the build phase, and environment is also top level for agent, scoreboard, and coverage. So there we will write the build phase, and here in driver to get the data, config data, we'll write the build phase, and run phase for main task execution. Sequencer, no need to write anything. And in the sequence, we no need to write the build phase. Just we need to write the main task body. In the main task
Where do
body,
we, where do we write in the driver? Can you show it in the driver again?
first I will show you how to write individually, then we will discuss.
Okay.
So build phases can be written in driver for reset operation or not reset operation to get the config data. So in the config data only we'll have the config data like agent is active or passive, everything will have. So in the driver we'll write the build phases, and also top level agent will write the build phases and environment. Okay. Next, how to write the build phase. Suppose I am taking a class environment. So environment or whatever extend from the UVM environment. So environment is a component, right? So we need to create the UVM component utils. Here we need to pass the, which one? Whatever the class name is there, we need to pass that. So no need to put the semicolon here. And in UVM environment, we will create the agent and scoreboard, because in agent we'll have, suppose here I'm creating it's not printing. Okay, so here I'm creating a agent, my agent, and name of the agent. So in agent, suppose if we take a active agent, the internal components will be there. Please mute yourself. Sequencer, driver, and monitor. If it is a passive agent, only monitor will be there. So in environment, I am creating the agent, and also we need to create the scoreboard. So scoreboard instance, I'm just creating like this. And then we need to create the constructor. So here I will pass some string. Class name, my environment, string name is equal to my environment, comma, what we need to mention, another argument. Component parent, you can put a parent name or else a null. Okay, next. Here pass both the name and also parent. Are you practicing how to write the UVM code, everyone? If you practice from small snippet, then you can able to write the overall code virtual. So why all functions or task, most of the functions or task in virtual in UVM? Build phase.
Use a concept of polymorphism.
Okay. So wherever we use the polymorphism concept, there we need to write the function virtual, task or function.
Yeah, I mean, if you are using the parent class.
Okay. So build phase. So what we need to write here in build phase? In
We need to
environment,
create.
in
We need to
environment,
create.
we declare two components, agent and a scoreboard. This agent is separately, suppose I am taking here as a agent dot sv file, and here I'm taking scoreboard dot sv file. So create file. So in agent again there will be um, sequencer, include the sequencer, driver and monitor. Okay, so individually we are writing in the agent. In agent again you need to create the build phase and create phase. I mean build is nothing but create and connect phase. Okay, so sequence, driver, monitor make the connections. How do we make the connections? Using the TLM port. Okay, so now this agent and this scoreboard we are running in a environment like this. Okay, so in build phase what we need to create now? Agent and scoreboard. So how do we create the agent and scoreboard? AGNT name. So agent is equal to my agent, scope resolution operator, type ID, and also create. Create, no need to use space. What we need to pass here?
AGNT.
Okay, same for scoreboard also. Whatever the variable you have taken, what SB. Type ID. Okay, so virtual function and function and class. Within the class only, within the same we can write build phase, run phase, create phase, connect phase, whatever. Okay, so this is how we create the components in build phase. Okay, clear everyone?
Ma'am, hello.
Yeah.
Regarding that question which you asked, why we use virtual, is it that answer is just because of we have same function in agent and these things, just because of
We will discuss
polymorphism
that
we are
thing.
using that?
We will discuss that thing. As of now, is it clear? Build phase,
Yeah,
how
yeah.
to make the build phase, everyone in the environment.
Uh, uh, yeah, this part is clear, but you also mentioned that it is recommended to use function and not a task, right? So I mean, if you use a task, this won't functionally not work, right? Because because this is kind of like
Wait. First of all, let me know whether everyone understood till here or not. We have lot of questions to discuss. First, let me give overview, then we will discuss about
okay.
virtual task function, where when to use and what will the error will get. Okay. So everyone clear? So next we are going to write the function connect phase. Okay, in the same here only we can write function So in the connect phase, what we are going to connect? Suppose you are taking a put port or get port one-to-one connection, or suppose you are connecting a monitor to multiple using analysis port. So how do we connect using the analysis port? Suppose Hello. In the agent here, in agent there will be a monitor and outside the scoreboard. So monitor to scoreboard. So how we can connect like that monitor to coverage report, suppose. So here, first of all, whatever the agent dot monitor dot connect for scoreboard analysis. Mostly if you connect multiple ports, we use analysis port or analysis export. In connect phase, we will just connect like this. Okay. In agent, if there is an active agent, we need to connect a sequencer to driver also. Okay. For example, if we see here, which one it is, go to agent. So if you see here agent in 18th line to 25th line. In build phase, we took driver 1, sequencer 1, and monitor. So all three are there. That means active agent. Okay. So in function void connect phase, we have created the driver to sequencer. Okay. Agent top level is environment. In environment, we will connect a monitor to outside the block, because within the agent means we will connect, but monitor is outside the block, we need to connect, right? So monitor to scoreboard 1 connection, monitor to coverage report 1 connection by using analysis port. Okay. So again, these things you can check in the coverage report how we are using here. In connect phase, we have okay, wait, monitor. So in the monitor, we declare the analysis port here. UVM analysis port, parameterized, and sequence item is a parameterized. Item collected port is the name of the here UVM analysis port. That's why here we have written as a item collected port, collected export. So in the scoreboard dot item collected export and COB dot analysis export. Okay, if you want to know particularly these things where we need to put export port, tomorrow session, I mean in the next session, you will get the clarity after TLM ports. Okay, so this is what connect phase. And in a test, in test top level, we just use the build phase where we connect the sequence, because sequence will be in a test, and also environment. Okay, so environment sequence we never connect. There will be no connection between the environment and sequence, but we will call top level, we will just call. Okay, so rise objection and drop objection in the run phase in test. Like this, rise objection, drop objection, we will discuss clearly. Okay, and next, clear till here everyone, how to write the build phase and connect phase? But practice is very important. I already shared this adder example. As of now, for practice, use adder example. We have some more examples in the maybe next week. We will try with some more example. Once everyone got clarity with this adder program, then we will work on with some shift register or counter UVM program. Okay. Clear till here, connect phase?
Yes, ma'am. Yes.
Next, end of elaboration. End of elaboration means final test bench topology and the settings will be done before simulation start. Okay, final topology. So how you want to print. Okay, so here how to write in the sense virtual function end of elaboration phase. These things are important. Default extending from UVM phase. Okay. So here we just need to put UVM top print topology. We have a lot of models. As of now, I'm using topology model and function. Okay, simply we can put like this in the top, test top. Okay, so UVM top dot print topology print the complete test bench hierarchy from top test bench onwards, test bench to top, test to environment, environment to agent, agent to sequencer, driver, monitor, like that. Everything will be printed hierarchy. Okay, and also it is very good in, it helps in debugging and verifying the component connectivity. Okay, so how the each component is connecting, like that, it will be very helpful. In this adder example also we have written, where here only see virtual function void end of elaboration UVM phase UVM top dot print topology. Okay, so if you observe, I can run and show how it is printing. See, from top test, it's a coverage report. Coverage report is not required. See here how it is printing from top UVM top environment in a hierarchy. In the environment there will be a agent, in the agent there will be a driver, and in the driver response port, sequence item port, methods, and in agent there will be a monitor, item collected port, which is analysis port. Here it is giving the response port means UVM analysis port, sequence item port means UVM sequence item pull port, like that. UVM monitor and sequencer. So what are the methods or we have written in the sequencer, like next coverage, scoreboard. So everything will be written in a hierarchical way. If you don't write like this, there are different ways, like a tree connection and also table connection, like that. Okay, so that is how we will print the topology. Clear everyone till here?
So is that a inbuilt UVM
Yes.
function that we got? Okay.
Yes, inbuilt method.
It only prints top to bottom, or we can also print from bottom to top like that.
Topology means only top to bottom.
Okay.
In reporting mechanism, we will discuss more examples.
Okay. One more doubt is we are using this keyword, no, ma'am. So that this represents to that particular
Same
parent.
class.
Oh, okay, okay.
We are accessing in the same class. That's why.
So in this case, class means we are using test like that, ma'am, or
Yes, in tester, here whatever add sequence is creating, these things we are accessing in the same class. That's why we are writing here anywhere this, and here also this environment is accessing. Here. Here
okay,
also
okay.
we need to put this. Okay, next, after end of elaboration, next phase is start of simulation. Start of simulation means it's just a UVM info statement. So how do we write in the sense virtual function void start of simulation. So these also we need to write in the same way. All these are predefined. You cannot write your own name. Okay. UVM phase. Next, here just a info statement or if you want to print any error statements, if else conditions, so like that. So simulation result. Start of simulation. Like that, whatever, we can write any name like start of simulation or starting the simulation. And we need to mention either verbosity levels. I already told you, right? Medium, low, or high verbosity level. Just a priority. We are putting the priority how to execute these things, statements. Okay. So verbosity levels also we can discuss in coming session. And next, end function. Okay. So in this, did we written anywhere start of simulation? Final report phase we have written. To get the report, I already told you, right? So coverage report or test pass or fail report, everything will get. If you observe here, we got everything here in terms of boxes. Even if you don't write the report also, we will get this box. Okay. So see report info for coverage. See this line, coverage report cov.text was generated successfully. Report phase is getting here. Okay. So it will print entire coverage report value here. So that's what report phase. Start of simulation. Okay, maybe in this code we didn't use the start of simulation. Normally we can, no need to use all the phases. Okay, so majorly we use build phase, run phase, connect phase. These three are very important. Remaining all are mandatory, not mandatory. Okay, end of elaboration, report phase. Okay, so clear everyone till here?
Prasanti, sometimes somewhere we use configure phase also, right?
Configure phase,
Some
configure phase, not configure phase, config db, just a file.
yeah, config DB is there. Somewhere I have.
Okay, configure phase in the sense in run phase, we have configure. In run phase, particularly, we have configure, main phase, configure phase. That's what you are talking about. So if you see here in run phase, we have reset phase, configure phase, main, shutdown phases.
Okay, okay. Mm. Okay, it's I mean subset of this.
Mm. Okay, so next, main run phase. In main run phase, what do we write? How do we write virtual task? Only run phase is a task. I will explain why it is. So and after the session, once from your side, check, put all the functions as a task and check if any error is getting or not from your side. Okay, in same session we cannot check with all, right? So once check and let me know what error you are observing. So in run phase, we can put phase objection and drop objection also. Okay, phase dot rise objection we call phase dot rise objection. That means start of simulation will be started here. Objection for synchronization purpose from first execution to last execution. Okay, for loop, whatever, for loop or repeat loop, int I is equal to 0, transaction class. So how we will create the transaction class? My transaction. Type ID. These are very important. Pranay, CB, Tamanna. When you are learning UVM, please try to remember these syntax.
Yes, ma'am.
Randomize method. So everything these all will write here, and also we need to put into the mailbox. I mean, we need to send the transaction to the sequencer, right? From sequence. Suppose this one we are writing in the sequence, or you can also use directly task body phase. Suppose if I'm sending to the sequence, then how I can send to the sequencer? The path should be sequencer is in a agent. So agent dot sequencer dot start method. In sequencer, we'll have the start method, right? So this transaction I'm sending like this, begin, end. After sending the transaction, whatever the phase dot rise objection is rising here, we need to write the drop objection also. Phase dot drop objection, so that both will be synchronized, and at the same time it will stop the execution. That means it will check whether received all the data properly or not at transmission side and receiving side. Okay, this is how we can write the run phase. In sequence, if you see here, mostly in sequence we write the task body only. Okay, that is mandatory, task body. And like this, and driver we use run phase. So if you see here, run phase, how sequence item port dot get next item drive, and sequence item port dot item done. You already know the execution flow, transaction flow. So like this. Clear, everyone, how to write the run phase and where to write the run phase? Only in the components we write the run phase, not in the objects. Okay, so that's why in sequence also we don't use run phase. In sequence we use task body. In driver we use run phase. And in monitor also component we use run phase. Sequencer is also a component, but in sequencer we don't write any implementation. By default, everything will be there. Mediator functionality will be there in the sequencer. Okay, remember, scoreboard also we write. In scoreboard, what will be there to write in the run phase? Just checking the uh, transaction, like comparison logic. So that thing we write in the run phase. And environment, monitor, driver. So whatever the components are there, mostly functionality wise, we write the run phase. In the objects, we never use the run phase. Okay, clear everyone till here?
Ma'am, this start function is inbuilt function, sequencer dot start.
Yes.
Um,
Yes.
and one more thing, that body does to in which phase does it come?
Body a sequence, not phase. It is just a task. Task
Uh,
body.
okay, means under the UVM phases, it is nowhere
Not
related
under
to
the UVM
phases.
phases. It
Okay,
is not
okay.
related to phases. We will just write the task body. In the task body, if you see before, the flow is there, this flow. In sequence, we need to create the item and wait for the grant from the driver, wait for grant, and here in driver get next item, and here we need to do randomize and send request. Driver will get the set data and waiting for the item done. So here it will send the item done response, so getting the response. So from sequencer to driver, the transaction flow is there. So whatever the sequence we are writing, all these things we need to write in the task body only. Okay, you cannot write the phases in the object. Sequence is the object. Sequence item is also object. But sequencer is a component. Driver is a component. Monitor is a component. Scoreboard is a component. Environment is a component. Agent is a component. Okay.
Yeah, okay, ma'am.
So if you see here sequence item is also object. We are declaring here object utils. Sequence is an object. So if you see here object utils, so that's why we don't write the phases here, only body. Within the body we'll write these things. Okay,
Yes, ma'am.
clear till here everyone? Till run phase, and then after run phase, extract phase. So in extract phase we collect the data, just info statement same as this function void start of simulation. Okay, ERTL CB.
Inside run phase, you have mentioned some other subphases, no, ma'am. Those phases are
In
just
driver,
for our reference, or we implement in some other places.
no need to use any every time, but if you see here run phase, here didn't mention.
Inside run phase, we use like
Uh,
reset
no,
phase and
driver we use, yes, reset phase, we use configure phase. Those are for more complex applications. Here we are not using any those type of complex data, right?
okay, okay.
So what should be run in reset? In system
Okay.
verilog, we have written run phase in main phase, run, sorry, reset, and then sending the data to DUT. Like that we divided in terms of task. But here we have phases, but maybe in the next example I will show you.
Yes, ma'am.
Next, check phase. Check phase is also a function. Suppose virtual function. Check phase. So what check phase in the sense, suppose counter value. You want to check some counter value, or input output transactions are equal or not. You need to check that. Okay, suppose I am taking the counter value as a scoreboard logic. I'm using as a 10 value, suppose. Okay, so here we will write the info statement. So whatever the output transaction at scoreboard, if it is equal to the count value info, um, what we can write here, test passed. In check you can write as a test passed, and also you need to put verbosity, UVM low or medium verbosity levels. Else, in else condition, suppose I want to write some UVM error. UVM error in the check phase. Better you can write, we need to write the phases also here, because from which phase you are getting the output you don't know, right? So check phase, run phase, like that. Check. Else statement, test failed. Test failed. So like this we can write check phase and function. Okay. So if the scoreboard count matches the expectation, then test is passed, or else we'll get the log file error. And then report phase, final phase. Report phase I already shown you here, right? For coverage, how the report is getting. So same function void report phase, UVM info get full name, which is written in the config DB. That data will be getting in the report phase. Okay, report final test. Next, final phase, clean up resources or test completion. It will be checked in the final phase, but not required. Okay, clear till here everyone about the phases, how to write all the phases, and
And
where
that
to
get coverage is implicitly defined method.
here, no?
Uh,
Get coverage. Here in config DB, for coverage, where we return the config DB. put coverage, put and get or config DB methods. These all are related virtual interface only. My coverage dot get coverage. My coverage is a name of the coverage. Get coverage is a method. Yes. Here get coverage is a method.
Like, ma'am, it's defined implicitly only, no?
Yes.
Okay.
Inbuilt. Okay. Next. So everyone got clarity, right? So where we need to declare each phase. Okay. So check phase. First four phases you already know. Build connector, end of elaboration, start of simulation, run phases. Coming to check phase we will declare in the scoreboard mostly. Here we have the check phase. Huh? Okay, here we didn't return the check phase, but write down clearly. So check phase we will write in the scoreboard. I have written the logic here, right? So comparing the actual value to expected value. And extract phase we write in the scoreboard or environment to extract the coverage data or any data. Extract phase in scoreboard or environment. Report phase we write in the test or coverage. Here we written in a coverage file, but also we can return in the test. Okay, report. And final phase also test or environment. For cleanup and closing the files we use final phase. Okay. Clear everyone till here? So my question is, suppose here everything we are writing in a virtual, right? So what will be the behavior? Suppose if like why are the all the functions and tasks declared as virtual in UVM? Is it necessary? Without virtual, what will be the behavior?
Ma'am, it will work without virtual keyword.
It will.
It will work, ma'am, because in the parent class, it is defined as virtual. But while we are using here, it's not compulsorily required.
Okay. Any other answers? Others?
So we can rewrite the function later.
Okay. Okay. So okay, in some cases it is necessary for functions and tasks. Okay, whenever we are trying to override in the derived class, mostly all the classes are derived classes only. Main parent classes are libraries. By default, this UVM test is the parent class, but this test is the derived class only. Whatever we are writing in the UVM, all are derived classes only. Okay, so whenever we are going to override the data, so obviously we use as a virtual. If a function is not declared as a virtual, the base class implementation will always be used, even if an extended class provide with more specific update. Okay, so that's why if you do not plan to override a function in the base class, then virtual is not required. Whenever we are trying to override, nothing but polymorphism concept or whatever. So whenever we are trying to override, definitely we need to put it as a virtual. Okay. Mostly run phases will be obviously virtual. Why? Because in run phase, the base test, if it is not virtual, it ignore the override data, overridden data. Okay, that's why mostly we put as a virtual. Why? Because everything we need to get from the parent class.
Ma'am,
And
in parent class, if it is declared virtual, then in the base class, it's not necessary, no, ma'am, to declare it as virtual.
in parent class, we no need to put virtual. In base class, we need to use the virtual functions.
But it will work, no, ma'am.
Yeah, it will work.
No, if we
Then
do not use the
from
virtual
where
keyword.
from where you are going to override which class to which class? Basically, if we don't use virtual, like common example, child class can access parent class properties anytime, but parent class cannot access child class properties, right?
True, ma'am.
So parent class, or we here suppose this UVM test is there. This UVM test is already defined. Parent class is already there, already defined. It's a library. Everything is predefined. So this test is a base class. This test is going to get the data from UVM test. But is it required to get UVM test from the test?
No, ma'am.
No. Then what is the use of writing in UVM test as a virtual? Here test is going to override. Test is getting the data.
Yes, ma'am. Yes, ma'am.
Am I correct?
Yes, ma'am.
Okay. Others, any doubts? Okay. Next question. So what question we left? Why all phases or function only run phase is task? What happens if we put all phases as a task?
Will take
Functions
a
cannot
lot of
have
time.
time delays.
Okay.
In run phase, we declare some statements which actually use it to run that design. We pass some inputs and we give the actual work of that design, ma'am. So it may take some time. So function will not take any time, ma'am. So task is a time consuming one, no? So we use task here.
Okay. But what happens? Suppose, okay, fine. Functions or immediate execution and whatever hash delay, or we have lot of things to mention delay, like event at the rate of event or wait state. These all are delays related, right? So I don't want to put anything in the task, okay, because function is at zero simulation running at zero simulation time. But in the task we are mentioning all these delays, okay, but I don't want to mention all these delays in this particular task, but I want to create all the phases using task, build phase, um, connect phase, everything I want to create using task. Is it possible if I don't want to mention any delays?
Ma'am, I think it is possible, but only thing by mentioning function, we are just forcing the derived classes not to use any delays into it, because we are anyway extending all these from the base classes or the parent classes. There it's all virtual, and we just don't want any subsequent derived classes to have any delays. So that's why we are forcing it by giving a function.
Okay.
Uh,
Others, any answers?
But build phase and connect phase, since it's we are getting it from the UVM root, right? So if we it's already like a prototype kind of thing, right? Like which we have to use it as a function.
Okay. Actually, if we talk technically, you can write other UVM phases like build phase, connect phase, everything as a task, but it is not recommended. Why? Because it breaks the UVM scheduling mechanism. First of all, why we are writing the phases in SystemVerilog? Already we have some concept of event regions, something. Okay, all those regions, whatever we are doing the randomization or whatever we are doing. This driver we are writing some reset task. After reset task, again we are sending some transaction data to dut data. So everything we are dividing into the task here. So if you see here in virtual task, so driver is one task here, getting the data and putting the data into one task. So everything we are dividing into separately task. Okay, so by using that, we are facing some limitations, like there is no proper time schedule between the all mechanism, all test execution flow. Okay, so from that limitation, we are using the UVM phases concept. Okay, so in that UVM phases concept, all are declaring as a function, because already we are facing some limitation with the driver. But even again, if we declare all functions as a task, then what is the use? Same problem again here also it will be repeated, right? It break the UVM scheduling. If we don't have proper schedule concept of test execution. Okay, so that's why it leads to some unexpected simulation behavior, internal tests. That's why only functions are preferred for phases. Run only task, remaining all are phases functions only. Okay, clear everyone?
Ma'am, I can't understand. Can you explain once again, ma'am?
Okay, suppose UVM schedule means what? If you see here in the PPT, we are dividing everything into particular schedule like this. Okay, so at zero simulation time, build phase, connect phase, end of elaboration, start of simulation, these things should be executed. And here in run phase, some run task should be executed, and here finally extractor. So here function, if we write the function, all these things will be executed at zero simulation time. And here these all will be executed at zero simulation time. But what is the major default with the task? Even if you don't mention the delay, task will not execute all at a zero simulation time. Okay, so I'm telling about SystemVerilog. Suppose in SystemVerilog in driver code, you already written the examples. For reset purpose, we use one reset task. To send the transaction data to DUT, we use one particular task. Again, in sending this, we don't send all the data in particular single clock cycle. We have multiple clock cycles, and also we need to get the data from mailbox and send the data to DUT. So everything we are writing in a task 1, task 2, task 3, task 4. So whenever we write in this way in SystemVerilog, we are finding some event region. There is no proper execution flow in SystemVerilog, right? So again, if you put all these tasks in a same way, here also we'll have some mismatch in the simulation, right? It doesn't have proper systematic execution. Okay, so it will break the function, it will break the task, and there will be lot of delays will be getting internally. It will break the scheduling mechanism. Okay, for that purpose we use function means everything will be started at zero simulation time. I never take delays. Okay, did you got the clarity now?
Yes, ma'am.
Okay, so this is major concept in UVM phases. I think everyone got clarity, but
Hi,
practice is important. Yeah, tell.
can you just repeat the last part that you just, sorry,
Which one?
about the phases, uh, the just picture that you shared.
Okay. So what I
Yeah,
am
this
telling
one.
means here I'm just comparing with the SystemVerilog test bench and UVM test bench. In SystemVerilog, we don't have any phases. We have task. Everything we are writing in a task. Okay. So what is the limitation we are facing there? Like a event regions, everything will not execute parallel at a time. At the output side, we may not observe that, but as I told before, there will be lot of long running simulations will be there, long running test cases will be there. Internally, we will observe those kind of delays by using the task. Okay, to avoid that, here everything we are using phases. Phases means all will execute at a same simulation time, at zero simulation time. For synchronization purpose, to break down everything in a schema, proper simulation structure, we are using a function concept. I will share you the recorded session. Everyone go through again. Okay. If you don't understand, then we'll discuss.
Yeah, thank you.
Okay. Any
Ma'am,
other doubts, others? Yeah.
Prasanthi,
uh,
extract phase in which component we use? In
Extract
the
phase we use in environment test.
in environment or in test.
Yes.
And check phase we use in scoreboard or in
Check phase, yeah, scoreboard or mostly scoreboard only, because we need to check the compare actual value and expected value, right? Check phase we use in the scoreboard. Extract phase we can use in any transaction now, and also report phase we use in a coverage. Okay. Final
ma'am,
phase in test or environment. Yeah, tell.
after end of simulation,
Extract
there are
phase
four.
we can also use in, I think we can also use in scoreboard. Not only check phase, in scoreboard we can use extract phase, because we are
because
getting
we need
data,
numbers. Yeah.
data to scoreboard, right? We can use in scoreboard also. Scoreboard and test environment. Yeah, tell.
Ma'am, after end of simulation, there are four phases, ma'am, like extract, check, report, and final. So this will happen serially, ma'am, one after the other.
Yes. Serially in the sense all are executing at zero simulation time. All functions will execute parallelly, right?
Yes, ma'am, that was my doubt. Like, is it first extract, then check, like that it should come, ma'am. But it's happening parallelly.
All will execute at a parallelly only, not serially. All functions at zero simulation time. Maybe the flow will be there. We do not tell as a sequential concurrent execution. All will be concurrent execution at zero simulation time.
Ma'am, if it is concurrent, let's say, ma'am, build phase and connect phase. Ma'am, if first connect phase happen before the build phase, then it will be a problem, no, ma'am.
That's why only we are waiting until completing internally, right? So why I given this diagram here? It should wait with one, everything is completed. 1 to 1.
Okay, like build phase and connect phase run parallelly, no, ma'am.
Build phase and connect phase run parallelly. Yeah? No, first build phase will run and then connect phase will run.
And then sequentially only they are running, ma'am. How can they run in parallelly?
But if everything will run parallelly, how can sequentially? How can we tell all phases are running zero simulation time?
Yes, ma'am, that was my doubt actually.
Okay. Any other answers from others? Any answer from your side?
defaultly inside the compiler, inside that UVM library, is there any customizations like one phase should run one after another, like build phase should run after actually connect phase should run after run phase, and run phase should run
Yeah, it
after
will be the same flow. Like first build phase will be run, then connect, then end of elaboration, then start of simulation. Flow will be in same way. Extract, check, because if first final phase, if
Mhm.
it run, how these phases
Yeah.
will be without running these phases, we don't get this report. Extracting the data or checking the data, reporting the data, we don't get these things, right? So that's why if you see start of simulation, end of simulation, these phases will execute at end of simulation. These phases it will execute at start of simulation. Pre-run phases, post-run phases. In the middle, time-consuming phase is the run phase.
So inside that library, will be there any inbuilt functions like that?
I think no, but I will check and I will let you know again. So these things will execute it serially only. At zero simulation time. Maybe we can tell it as a concurrently. Concurrently means what? Either not serially or parallelly. Okay, according to its delay, those will be executed. Okay,
Yes,
we
ma'am,
will.
so they're executing like serially only, but it consumes zero simulation time. Like
Yes.
that we can put it.
Yes. Yes.
Okay. Actually, my doubt is there any functions or statements which is inbuilt to maintain that flow?
Inbuilt, there will be lot of things, or else how we can use all these things. Inbuilt,
Okay.
everything will be predefined in the library. In UVM library. That's why everything we are getting from parent library, right?
Yes,
Even
ma'am.
if you write here, whenever we are writing the phase here, UVM phase, what is this UVM phase? Nothing but parent.
Yes.
So whatever
Yes,
we are taking here, so everything will be predefined. We are not writing actual functionality of the phases. We are just connecting, we are making use of the phase.
okay.
Okay. Okay then. So if you have any doubts, we'll discuss in the next session. Okay.
Ma'am, another last doubt.
Do you have any doubts, Vinita?
No, it's all right. Thank you.
Gurshant? Sampriti? Vishal? Kirti?
No, ma'am.
No, ma'am.
Okay. Gurshant, did you understood all the topic, whatever we discussed today? Okay. Okay. Yeah, who is that? Ash.
Yes, ma'am. Like, ma'am, at the end of the course, we'll do a project, ma'am, related to AXI.
Yes.
And that, is it like what AXI bridge or something, or AXI
Not
protocol
AXA
only?
bridge, AXA protocol, AXA VIP development.
Okay.
Okay. But we are not going to discuss everything point to point. We'll discuss what are the major things they are required. You need to practice from yourself. Okay.
Okay, ma'am. Ma'am, will you teach that how the protocol will work?
Yes.
Okay.
Okay. Okay, then thank you all.
Thank you, ma'am.
Thank you.
Thank you, ma'am.